Decision analysis can be used to determine an optimal strategy when a decision maker is faced with several decision alternatives and an uncertain or risk-filled pattern of future events. For example, a global manufacturer might be interested in determining the best location for a new plant. Suppose that the manufacturer has identified 5 decision alternatives corresponding to 5 plant locations in different countries. Making the plant location decision is complicated by factors such as the world economy, demand in various regions of the world, labor availability, raw material costs, transportation costs, and so on. In such a problem, several scenarios could be developed to describe how the various factors combine to form the possible uncertain future events. Then probabilities can be assigned to the events. Using profit or cost as a measure of the consequence for each decision alternative and each future event combination, the best plant location can be selected. Even when a careful decision analysis has been conducted, the uncertain future events make the final consequence uncertain. In some cases, the selected decision alternative may provide good or excellent results. In other cases, a relatively unlikely future event may occur, causing the selected decision alternative to provide only fair or even poor results. The risk associated with any decision alternative is a direct result of the uncertainty associated with the final consequence. A good decision analysis includes risk analysis. Through risk analysis, the decision maker is provided with probability information about the favorable as well as the unfavorable consequences that may occur. We begin the study of decision analysis by considering problems having reasonably few decision alternatives and reasonably few possible future events. Influence diagrams and payoff tables are introduced to provide a structure for the decision problem and to illustrate the fundamentals of decision analysis. We then introduce decision trees to show the sequential nature of decision problems. Decision trees are used to analyze more complex problems and to identify an optimal sequence of decisions, referred to as an optimal decision strategy. Sensitivity analysis shows how changes in various aspects of the problem affect the recommended decision alternative. The decision theory process consists of 5 phases. Firstly, clearly define the problem. Secondly, list all possible alternatives. Third, identify all possible outcomes for each alternative. Fourth, identify the payoff for each alternative and outcome combination. Fifth, use the decision modeling technique to choose an alternative. Well, how the decision theory is applied. Decision theory can be applied in 3 different ways. First of all, decision-making under certainty. Secondly, decision-making under uncertainty. Finally, decision-making under risk. A condition of certainty exists when the decision maker knows with reasonable certainty what the alternatives are, what conditions are associated with each alternative, and the outcome of each alternative. Under conditions of certainty, accurate, measurable, and reliable information on which to base decisions is available. The cause and effect relationships are known in the future is highly predictable under conditions of certainty. Such conditions exist in case of routine and repetitive decisions concerning the day-to-day operations of the business. Most significant decisions made in today's complex environment are formulated under a state of uncertainty. Conditions of uncertainty exist when the future environment is unpredictable and everything is in a state of flux. The decision maker is not aware of all available alternatives, the risks associated with each, and the consequences of each alternative or their probabilities. The manager does not possess complete information about the alternatives, and whatever information is available may not be completely reliable. In the face of such uncertainty, managers need to make certain assumptions about the situation in order to provide a reasonable framework for decision making. They have to depend upon their judgment and experience for making decisions. When a manager lacks perfect information, or whenever an information asymmetry exists, risk arises. Under a state of risk, the decision maker has incomplete information about available alternatives, but has a good idea of the probability of outcomes for each alternative. While making decisions under a state of risk, managers must determine the probability associated with each alternative on the basis of the available information and his experience. We can say about this method that probabilities of the possible outcomes are not known. This method can be applied such as max-I-max criteria, max-min criteria, criterion of realism, equally likely criteria, min-I-max regret. When we assume the best payoff will occur for each alternative, the most profitable alternative can be chosen. If you want We can solve the problem related to this topic together, so we can better understand the subject. A logistics firm is planning to add one from vehicles with 5, 10, 15, 20, 25-ton transport capacity to the vehicle fleet in anticipation of customer demand. The company offers the service price to the customers of €10 per ton, and the cost per ton is €7. Accordingly, the logistics firm should buy which one? First of all, we can start with creating the decision table as shown in presentation. As shown in the presentation, each alternative has different gain and loss values in the frame of varying nature situations. According to the optimism criterion, we set the highest values for each row. We can choose the highest value among these values. Therefore, the alternative which provides this value can be chosen. This means that if everything goes well, you can obtain the highest benefit under uncertainty conditions. According to the optimism criterion, the fifth option can provide the highest benefit. So it would be best to add a vehicle with a capacity of 25 tons to our fleet. According to the pessimistic criterion, we can start with determining the smallest value in all rows. These values represent the highest values of costs that we will endure if the worst scenario occurs. We can choose the smallest value among these values. As can be seen in the table, second alternative can provide the lowest cost. So choosing the second alternative may be optimal. The criterion of realism, or another name is a Wiggs method, is a compromise between the max-I-max and max-min criteria. The decision maker is neither totally optimistic, as the max-I-max criterion assumes, nor totally pessimistic, as the max-min criterion assumes. With the Wiggs criterion, the decision payoffs are weighted by alpha coefficient of optimism, a measure of the decision maker's optimism. The coefficient of optimism, defined as alpha, is between 0 and 1. If alpha equals 1.0, then the decision maker is completely optimistic, and if alpha equals 0, the decision maker is completely pessimistic. For each decision alternative, the maximum payoff is multiplied by R and the minimum payoff is multiplied by 1 minus alpha. For our example, if alpha equals 0.6, that is, the company is slightly optimistic, and 1 minus alpha equals 0.4, the following decision will result. The decision maker attempts to avoid regret by selecting the decision alternative that minimizes the maximum regret. A decision maker first selects the maximum payoff under each state of nature. Then all other payoffs under the respective states of nature are subtracted from these amounts. These values represent the regret for each decision that would be experienced by the decision maker if a decision were made that resulted in less than the maximum payoff. The maximum regret for each decision must be determined, and the decision corresponding to the minimum of these regret values is selected as seen in presentation. The equal likelihood, or Laplace, criterion weights each state of nature equally, thus assuming that the states of nature are equally likely to occur. Since there are two states of nature in our example, we assign a weight of 0.50 to each one. Next, we multiply these weights by each payoff for each decision and select the alternative with the maximum of these weighted values. According to the optimistic criterion, as shown in the fifth alternative, the pessimism criterion and the Wiggs method can be selected as the second alternative according to the greatest regret criterion and the fourth alternative according to the Laplace method. Please consolidate your knowledge by solving problems with different values. See you in the next chapter.